So you guys already got to see a little preview of some of the toys we're going to play with today. So we had our buddy, who knows our buddy's name? Duke, yes. Lego, what's his Lego Duke? His evil cousin. We also have a homebrew tablet. This is a tablet built from scratch using a Raspberry Pi and a laser cutter. But you could build one of these yourself. Speaking of Raspberry Pis, I've also got a Raspberry Pi development board hooked up to a breadboard and some sensors we're going to play around with. And I also have some tablets and consumer devices which you probably don't even know that Java runs on. How many folks have an Android tablet on you? Or phone? Phone. OK, how many of you folks are running any JavaFX user interface on your Android tablet? OK, so hopefully I'll encourage you guys to try that out. OpenJFX, which is the open source JavaFX, runs on Android. It runs on iOS. And you can cross-port across desktop as well. Yeah, so hopefully we'll have fun. For the presentation, feel free to interrupt me at any time if you have questions. When I'm showing demos, feel free to also hop up closer to the front. It's probably a little bit easier to see what's going on if you get closer to the front rather than sitting too far back because all the devices are up here. And I'll also give you guys a chance to play with the devices as well. So you can be a little hands-on and play with the devices in person. Does anyone have an idea? I had some earlier footage up of some snowmobiling. Anyone have an idea where I was on a snowmobile? Take a guess.
Norway, Sweden.
OK, I think Finland's. Okay. But that's really close. So I've been trying to get out about yearly to do a cross-country or cross-continent motorcycle / evangelism tour. So this year it was France, Spain, Germany, Italy, I don't know, a whole bunch of European countries. I did the northern European countries before. Unfortunately, it was a little bit too cold for motorcycles. And you can watch all the videos, which I've been recording as I go around and interview folks and also speak at conferences at nighthacking.com. So I carry a setup kind of like that, except on my back, and then try to record as much as I can and post it. So here's some of our devices we're going to play with today. Let's see if I got them right. Lego, Raspberry Pi, DukePad. I'll show you Java running on iOS and also Java running on Android. So hopefully at least one of those is something you're interested in seeing. So first, a little bit about Java running on devices and in the larger picture of the Internet of Things. So this is a projection by Cisco on the number of devices per person. Probably, since we're all technologists in the room here, we're slightly ahead of the curve in terms of number of devices we have. I asked earlier how many people had cell phones and tablets, and a whole bunch of people's hands went up. Does anyone have one of the Fit bands or step monitors? Yeah, right there. So it's a wearable, Android wearable. So it tracks your activity levels. Very nice. Does anyone have a home automation system at home? Something which will, OK. Does that do security or garage door or lighting or?
Mostly just lighting.
Lighting.
And also sprinkler control.
OK, and you probably heard the recent announcements from Oracle or Apple and Google, where they both announced big offerings in the home automation space. And this is also happening a lot in healthcare, industrial automation, industrial building automation. It's already been taking place on assembly lines and places for industrial automation. So there's a whole bunch of industry verticals, both consumer and industrial, where you're seeing more devices. And right now, a lot of these devices will talk directly to kind of an isolated cloud service. For example, the lighting system you have, is that just self-contained, or does it also talk to a vendor cloud?
It's self.
OK, so that's good. Nobody's going to hack your house and start playing with your lights. A lot of the new offerings are threatening to be cloud-based, where they'll hook up and they'll be more integral in your life. But at the same time, you're probably hooking up to a proprietary backend. Ideally in the future with different collaborative systems and mesh networks, there's a new initiative from Qualcomm called Alljoin, trying to get devices to talk to other devices and gateways and have more interactions at a local level and be somewhat vendor neutral. So Java is a good part of this ecosystem because it lets you do more advanced networking, communication on devices, and you can do processing which would allow you to have devices actually have some logic on them rather than deferring to some sort of cloud service or something which would actually control the process. And it can run on really tiny devices. So this is the EHS5 chip. This is made by Gemalto/Centurion, their subdivision. And it's really, really tiny. It fits in about the size of your finger. And besides having a Java ME capable processor on it, it also has a 3G processing capabilities like a cell phone. So it can do long-range communication. You just attach an antenna to the right pinouts. And you can actually both put your business and application logic in Java and also do communication across the 3G band. So one of the applications they used a chip like this was in the Amazon for tree deforestation. They would put a little EHS5 chip plus a battery and an accelerometer and a GPS. And then, usually accelerometers don't really trigger for trees. Trees don't really move. So that was probably a sign that the tree was cut down and being taken away somewhere, and then they could, call back home with 3G and track it on GPS and catch the folks who were doing the deforestation. So for the guys in the back there enjoying the comfy table, can you mostly hear me? Yeah? Okay. I opted not to use the in-room audio because it was a funky, slightly funky mic. But if you guys have trouble hearing me, let me know, and we can try the in-room audio and see if it's better. So this is what the world looked like in Java 7. You can see Java SE is the big blue circles. Java ME is the transparent and the yellow circles. And there was quite a bit of divide between the two different API sets. This is mostly historical, right? Java ME came from the mobile phones, and it has quite a history behind it. But it also wasn't kept up to date in the latest Java standards. So if you were doing Java ME on Java 7 or prior, you had to be using JavaOne 3.1.4 language specs. This got a lot better with Java 8. So the language level of Java ME got significantly increased. It includes almost everything except lambdas now. And the APIs, they added more of the Java SE APIs to Java ME, and vice versa, moving some of the device APIs back to Java SE embedded. And the goal is to have Java ME and Java SE be a common platform you can build for, but just differentiation on the size of devices you're targeting. All the devices I'm showing you today, I'm actually going to be running Java SE embedded. And I'd recommend if you guys are trying out embedded Java, Java SE embedded is a little bit easier to get started with. It's exactly the same APIs as on the desktop if you're using Java SE embedded. The only difference being that it's optimized to run on small devices. And depending upon the device you're using, you might have some limitations, and I'll mention those as we go along. But for the Raspberry Pi, that's the reference implementation or reference platform for both Java ME and Java SE. You would typically run Java SE on devices about the Raspberry Pi size or larger, since they have much greater capabilities. If it's smaller than a Raspberry Pi, then you'd typically be running Java ME, so you can get better performance. So the early example with the EHS5 chip, that chip only supports the Java ME because it's a Cortex M3 processor, I believe. So it's not quite powerful enough, and it doesn't have enough memory where you could run Java SE with full performance. OK, and then if we have any C hackers in the room, any C embedded hackers? A little bit? OK. So if you've tried doing C development on embedded devices, then you've probably run into the typical problems of portability, easy to use libraries, a large community, and all the things which have plagued C on embedded devices for a while. Java hopes to fix a lot of these problems for the embedded industry because it has a large community of developers like all of you guys here who are Java hackers. It brings garbage collection and modern language constructs with Java 8. Now you can do lambdas on embedded devices and should make it a much easier and more portable development environment to get started with.
What is sandbox security?
Sandbox security model. Oh, so that's Java allows you to sandbox your application. Like when you have an applet running in a browser, it only has access to certain things, certain permissions. So you can use the sandbox security model on your embedded devices as well. That way your application doesn't have full access to the entire device, and you can install, for example, third-party plugins or things safely. OK, and excellent example of what you're supposed to be doing. Interrupt me at any time for questions. And occasionally, I'll actually remember to repeat them for the camera. The earlier question was, what was the sandbox security model? Oh, and for more information, visit our IoT community site. But I think that's enough about IoT. Let's play with toys. So our first toy is going to be Lego Duke. And he is, question, yeah?
I'm sorry. I'm sure you got this question all the time. I know, isn't there like a subset of JavaOne wasn't there a dispute about that, or all JavaOne?
OK, so I'm not an expert on the differences between Java running on Android versus Java running on other devices. But all the stuff I'm talking about is the Oracle Java distributions and stuff based upon the Java community process. And for legal reasons, I'll no comment on anything related to Google Android specifically. Other than, I'm going to show you guys OpenJFX, which is open source JavaFX running on Android tablets. And that would probably be a more appropriate time to ask Android-specific questions related to that. OK, so there's 3 different versions of the Lego Mindstorms. The left one is the RCX, the original one. Anyone have one of those? All right, so we're showing our age. But it was really cool when it first came out. It was like the first hobby programming Lego kit. You could do lots of cool stuff with the motors. Not the most powerful processor and capable unit in the world. The NXT got a lot better. Better sensors, nicer design, and more powerful processor. And the EV3 is really what you should be getting now if you were looking at getting a Lego Mindstorms kit to play around with. So this Lego Duke is built using the EV3. The biggest difference between the EV3, well, the biggest difference I care about is this one has an ARM processor that's powerful enough to run full Java SE embedded. So the previous 2 units, the RCX and the NXT, you had to cross-compile your code. So it would cross-compile your Java code to native code for device. With the EV3, it's powerful enough that it runs a full Linux distribution, Java virtual machine, and then you can just copy jar files from your desktop and they'll run directly on device. So it's kind of nice. It's exactly what you'd be running on desktop. Just the embedded version, 64 megabytes of RAM, 300 megahertz processor, motor and sensor ports, and it even has integrated Bluetooth, so you can directly hook up to it from your computer if you have Bluetooth capabilities. I'm using a Wi-Fi dongle. There's also a USB cable that comes with it. And you can load up your operating system on microSD. I think with I didn't try this with the NXT, but I think you had to flash the ROM directly on device because it didn't have loadable memory. So if you wanted to do the same thing on the NXT, you actually had to kind of overwrite the Lego firmware to get any other operating system running on it. But if you take out the SD card in this, you're back to a normal Lego brick, just like you haven't modified it. All right, so our Lego Duke has 4 legs, large motors on his wheels, so he can self-balance. He has 2 wheels, so he's kind of like a Segway. Just without the Segway's built into his legs instead of him sitting on it. He has a gyroscope, which is the one on the left there, to help with balance. So that's how he knows when he's going to fall over, and he should self-correct. And a simple button for starting him and giving him controls. The EV3 kit also comes with a light sensor you can use for detecting ambient light, picking up colors, following lines. A ultrasonic sensor, which lets you check distance. This comes with the education kit. So if you get the retail kit, you don't get the ultrasonic sensor. You get the infrared sensor instead. And I'm actually using the infrared sensor plus the remote on this guy so we can control him via a little Lego remote. And then to get started with LeJOS, it's really easy. You need to at least get an SD card. Sometimes the Wi-Fi adapter is helpful as well because pairing via Bluetooth and USB can be slightly more complicated. But both of those are possible and not that hard. There's more instructions on their SourceForge site about how to image your initial SD card. It takes, from scratch, probably an evening of hacking to get your first Lego program deployed and running on our Duke or on your own Lego set. So fairly easy. You could even get your kids set up with them. And this is what a very simple NXT program looks like, minus a few typos. They changed the API since I wrote this. So we will get you 100% correct. OK, now it's 100% correct. So very simple. You import the LeJOS libraries. LeJOS is an open source library for running Java on Lego Mindstorms. And you're sitting on top of the Java SE embedded build, which Oracle releases. And this is a very simple program which is going to write some text to the LCD screen, wait for a press, clear it, and then refresh. So really easy to get started. Actually, I just did a lab with a bunch of kids. Dun, dun, dun. Let's see, are any of these networks easy to get on, or should I not bother? Where's our pub number? Awesome, thank you. So I was just doing a kids workshop with DevOps for Kids, which is an organization that, here are the kids. They're an organization in the Bay Area. It was originally started in Belgium, but there's a new Bay Area chapter that Arun Gupta runs. And we were doing a Lego workshop, or a Raspberry Pi workshop, but just a couple days ago, last Thursday, we had our first Lego workshop at Oracle. Let's see where it is. Legos. OK. So this is a little project the kids put together in about 3 hours in the afternoon from scratch. So I gave them basic instructions to build a wind turbine, some very simple code to get started with, kind of like what I just showed you on the slide, to show them how to use the big motor, the medium motor for the fan, and then the light sensor. And a bunch of the kids successfully got the little wind turbine to rotate, do light sampling to find the brightest spot in the room, point that direction, and then spin the fan. So they were pretty successful in that. Oh, and I even have a video. Let's try this. OK, so here's a little sample of one of the kids' completed projects with a little fan going, and then it's sampling. I think he probably did every 45 degrees to check it for different light readings. And then it compares those and then points towards the brightest area and spins the fan. So not bad for about 12-year-old kids. So if they can do it, then you guys can probably get some Java embedded projects working pretty easily on the Lego Mindstorm. So does somebody want to help me out with this guy? And I'm going to hook up to the Lego Mindstorms on the console. Since I changed my networking, I just lost all my connections. What is the IP address on his backpack say?
10011.
The second one.
10013.
OK, good. It hasn't changed too much. All right, so I'm launching it from my computer via an SSH connection, but the application's actually running on the device itself. You can start it via the menus if you wanted as well. LeJOS has a new menu system. So the way this works is he has to be perfectly still to calibrate the gyroscope. So to make it easier for folks to see, let's, I don't know.
This is going to move the table.
Can we move the table out of the way for a sec? Is that OK? Here, I'll put your water. Yeah. Let's move the corner here. OK, and now we can put it on the ground here to have some more room. So if you want, just stand up and get closer so you can see a little bit easier. So the first thing you want to do is lie him on his back. Make sure he's still. And when you press the button, it's going to first calibrate, and then he'll start beeping once he's calibrated. As soon as he starts beeping, stand him up on his legs and try to get him balanced about in the center of gravity, give or take. So it's slightly leaning back because his nose is too heavy. And then after that, we'll see if we can control him via the remote. So let's try balancing him. So
Where's the button?
right in his hand. Now lift him up. Now let go. Oops. We'll try again. Oh, one of his wheels was popped out. OK. So not your fault. One of his motor ports has popped out. OK, let me restart the program to make sure. Sometimes if you unplug the motors while he's in the middle of running, it's not going to immediately recognize the new motor. You can press the button whenever you want, but until it gets far enough along, it won't register the button press. So it'll say gyroscope ready or something in a sec. It's only a 300 megahertz processor, so it's OK to do semi-real-time stuff, but it takes a while to get booted up. There we go. Now he's ready. All right, good. Excellent work. And where's our remote? Oh, here we go. OK, so the way this remote works is the top two buttons are for steering. So you want to aim at his buttocks, where the sensor is, the infrared sensor, and just click it once or twice, and he should rotate. So you might want to get behind him. Yeah. Each time you click it, he goes faster, kind of like that. The carpet here is a little bit thick, so he might have a little bit of trouble balancing. OK. Yeah, so get behind him again and try to press left, right. That's backwards, bottom right. Forwards is here, left, right. And you have to get behind him again because you're facing away from the IR sensor. OK, he's balancing, but occasionally, can you grab him for a sec? Oh, there he goes. OK, the big button stops him if you want to stop immediately. There you go. And that one goes backwards, but you have to get behind him a little bit. Oh. All right, great work. Give him a round of applause. So, lots of fun. My daughter helped me build the model as well, and she's only 11. So this is a good project for kids as well. But even big kids can have fun with this stuff. So there's a,
Can you repeat the question?
can you repeat, well,
The auto balancing functionality of that, is that something you got to write specifically as part of this particular project, or is it something else?
okay, so the question is the auto balancing stuff something which comes with the Lego Mindstorm set? And the education set actually has an example project of a gyro boy, which is a little self-balancing robot much smaller than this. And there is one in the funky like brick diagram thing where you draw lines to each other. So that program is so complicated with so many subroutines and special parameters and stuff they had to get it to do to work that I guarantee no child, well, and no person under the age of 18 could figure it out or do it themselves. So you can use their software, which kind of is already pre-built by one of their Lego experts who uses their funky brick modeling stuff. The algorithm I'm using is simply a port of the C code. So it's exactly the same algorithm the Lego code uses, but you can read it and understand it, which is a big help. And you can debug it to fine-tune it. One of the things about balancing is the larger the model, the more difficult it is to get to balance. So I tried with their software and was very unsuccessful getting a large model like this to balance. But in Java, it was much easier to fine-tune the parameters and make it work. And just for fun, we're taking him apart. Originally, he didn't have any parts glued together at all, but after he broke apart on stage at JavaOne, I decided I might have to break down my principles and do a little bit of gluing. So he's glued in some large chunks, which mostly stay together. But this lets you see the inside of him. So the arms are actually connected to motors, so they can wiggle slightly. You can see the gyroscope in the center here. I'll pass them around so you can get a closer look. But there's a gyroscope in the center, which helps with balance. And then the two large motors and then the two sensors hanging off the side with wires. So.
Are there websites where people kind of put up their code to kind of share amongst the community that's interested in doing this?
So since I worked with the LeJOS guys on this code, they actually published the Segway code. So you can get that off the LeJOS website. The LeJOS guys have a bunch of other examples as well. For the windmill example I just showed you, I've posted that code as well, so you can check out that project as well as build instructions. So I have like a picture-by-picture guide for building the windmill from scratch. So I think this, yeah, so if you go to my blog, steveonjava.com, then you should find the windmill instructions and sample presentation and all that stuff.
Can you buy this model from Lego, or did you completely customize it yourself?
This model has the large wheels from the expansion set. It has, most of the parts are from the core education set, but then I separately purchased the infrared and the remote since those only come with the retail kit. The windmill kit, which I did exclusively from the education core set. So you can just buy the core set and build it from scratch. And it was designed that way so it could be workshopable for kids, and we could just get them a single set and it would be easy to build. And of course, you know, this is all custom, buying bricks on eBay and putting it together by hand. So it's fun, but it's hard to replicate. OK, so any other questions about our Lego guy before we have the next fun hardware project? OK, so the next thing I want to show you is the Raspberry Pi. So I've got a Raspberry Pi here. He has a little LCD screen. This is just a kit from Adafruit, which hooks up via the I2C bus. I have a portable battery, just a normal cell battery. Any battery or power supply which supplies an amp of power is fine for powering the Raspberry Pi. And it uses a normal micro USB slot for the charger. And then I have a breadboard hooked up with some other devices where you can see interconnecting physical devices with the Raspberry Pi. I think the most interesting thing about the Raspberry Pi and embedded devices is not to use it as a general purpose computer, but instead to do some cool hardware hacking or integrate it with something. For example, if you have a lighting system in your house, I'm sure you could take a Raspberry Pi and hack it together as an extra controller, or maybe to control window blinds or your garage door or something, and then integrate with your existing system. So it's very inexpensive. How many people have a Raspberry Pi so far? Okay, so about a third of the folks. Everyone else, it's only $35. You should just go buy one. It's basically, what is that, like a week's worth of Starbucks coffee? Very inexpensive, and they sell bundles which come with power supplies and breadboards and all the parts. But if you want to do it on the cheap, you can just buy the board itself, use your cell phone charger, wall wart, to power the Raspberry Pi, hook it up via an HDMI cable to the TV in your living room, take an old keyboard and mouse and plug it up, and you've got a functioning Raspberry Pi. So you can actually do it very inexpensively. You don't need to buy the fancy kits that are $100. So the hard drive for the Raspberry Pi is a simple SD card. Usually they recommend getting at least an 8 GB SD card. It used to be 4, but I think that you're going to have trouble fitting the current Linux distributions on those from the Raspberry Pi Foundation. And it also has capabilities, like I mentioned, for video output, audio output, and GPIO pins. You could hook it up to Ethernet, put host USB devices on it, so it's quite capable. Another nifty device, which is probably worth the investment, is getting a Wi-Fi dongle. So the same Wi-Fi adapter I use for the LEGO Mindstorms, I have hooked up to here. It's a, what is it, an Edimax WNA something or other. It's listed on my earlier slide for the LEGO Mindstorms, but that also works with the Raspberry Pi. So anybody want to take a guess what these two funky adapters are on top, connectors are on top of the Raspberry Pi? What? Okay, so camera is one. Good job, Sasha. Yeah, very good. Second one is a display. So for the camera, you can buy the PiCam from the Raspberry Pi Foundation. And it's a little inexpensive pinpoint camera that works with the Raspberry Pi. It's kind of nice. I have one of those inside of the Duke pad in the back. The display port is currently unusable because it goes through the GPU, which is a closed system. So until the Raspberry Pi Foundation comes out with a compatible touchscreen, the rest of us are stuck without a proper display. But what we used for the Duke pad, and it's a good workaround, is to use a touchscreen like this. This company, Chalkboard Electronics, makes a little inexpensive touchscreen. They're based out of Malaysia. Their 10 inches are $130, although I kind of like their 7 inches better, and they're slightly cheaper. And they hook up the Raspberry Pi over HDMI and touch via USB. So it gives you similar capabilities to if you're using a dedicated touchscreen port, except it adapts through the connectors the Raspberry Pi has on it already. And if you buy from them, you can use that discount code to get a small discount. So feel free to take advantage of that if you're going to order from them. OK, and this got a lot easier. Now Java is installed in the direct Raspbian distribution. But you can go to my blog, steveonjava.com, and find out more information about getting started with the Raspberry Pi in Java. And we're gonna play around with this little sample project. So what I have here on the breadboard is a little analog to digital converter. The LEGO Mindstorms has this built in by default. So they have the ability to add analog sensors built into the device. The Raspberry Pi, all the GPIO pins are digital only. So if you want to add an analog sensor, like these pressure sensors or the light sensor I have hooked up, you need a little analog to digital converter like this board, which I got from Adafruit. So that's hooked up via I2C, just like the display is here. And we're going to see how strong the the San Francisco Java user group members are. So I have this, this board hooked up so it uses the Bonjour protocol or Netatapi to make it easier to connect to. So I'm referring to it by its Bonjour name. And then logging into it. I have a couple programs which are already installed on this. So we'll try the pie plate sensors. Now I think, let me check. I was playing around with this earlier, and I think I might have some Java processes already running on this, if I can type. Or maybe not. All right, so we're going to run the pie plate sensors program. And the idea here is it's going to display the force and the photocell resistance when we press in these buttons on the, or these sensors, when we touch the sensors on the board. So who's the strongest member of our user group, Sasha?
I don't know. Maybe Gordon wants to volunteer.
So, strong, I'll give it a good shot. Where's it at?
All right, so this is the pressure sensor. If you pull it, it will come out of the board. It's not a big deal. But just squeeze it like that, and it'll raise the values here.
Okay.
If you guys want to see the board, feel free to come up. Okay, how are you doing? 1450, I saw. 1470, yeah, 80. Almost 90. 1500, ooh, oh wow. All right.
It's starting to hurt a little bit.
Good job, good job. No, 1500 is really good, so good job. You want to try the light sensor? The way the light sensor works is you, the second number here, let's have someone else try that.
What's the unit of the force sensor? Like it's
Typically, these force sensors are better for on-off type applications where you either pressure or you don't, because they're somewhat variable in the scale. And depending upon what resistors you use, you'll get different numbers as well.
okay.
But with this particular setup, I think it ranges to about 0 to 2000-ish.
Okay.
All right, so someone else want to try the light sensor?
Sure.
Yeah.
It's this one?
Yeah, and then the number you're shooting for is the second one, which is currently in the thousands. You can touch it.
Like it's 0?
Oh, cool.
Yeah, get as close to 0 as you can. Oh,
Is it
your finger's putting too much light through. It's not a pressure sensor. Pushing doesn't help.
Oh, I see. I guess this helps.
That helps. All right, yeah, down to the hundreds. I think the lowest I've seen that is in the teens, maybe like 20-ish.
I think this is conducting, right? So you can skip.
Oh yeah. That's pretty good.
Makes sense. Sure.
All right, so if anyone else wants to try, you can give it a try. But that shows you a really simple example. You can see it's definitely like home custom wiring. Occasionally one of the wires pops out and I have to try to remember which one is the right I2C bus, or whether I put it in 3 or 5 volts the last time. But it's fairly easy to set up as well. Something you could do at home in a weekend. Okay, and this is a slightly bigger home project. So we got the Duke pad. Let me see if I can pull them up a little. So it looks like a tablet. Sorry about the light. Again, this is a homebrew thing, so maybe I can tweak it a little. Okay, so the brightness of the screen is relative to this little light sensor here. And he happens to be next to an LED, which usually works as a little workaround to cut off the light sensor. But he kind of fell out of position now, which is why the screen is slightly dimmer than it usually is. But this whole design is all based around the Raspberry Pi. You can see there's a Raspberry Pi unit in the top left corner. Some of the ports are exposed on the side directly, so you can put the SD card in and you can access the audio jacks. The other ports are replicated out the side, so I have a splitter for the HDMI, USB hub so you can access the USB ports. And normally there's a battery here to power it, although I took that out so I can do a video splitter to get it to go to video. Actually, why don't we try that, just for kicks. Oh, I see. No, that's not going to work. Where is this going to? All right, so now we get to see the internals, because I'm going to do something which you should never do during a presentation. I'm going to take my device apart and attempt to insert the HDMI cable directly in. You out. All right, any luck? Nope, it's still on here. Sometimes it depends on the receiving device. Some devices don't like certain HDMI signals. But this apparently does not like the one coming out of the device. Oh, there we go. All right, so we have video now. So now you guys can see exactly what's on my screen up on the big screen over there. OK, so this entire operating system is done using, well, the tablet UI is done using JavaFX. So there's a login screen, which I've already gone past. It also showcases some of the new JavaFX 3D support, which was released in Java 8. Anybody tried Java 8 at all? OK, a few people. What's your experience been like so far? That's exactly. If it's an uneventful upgrade, it's a good one.
Yeah, I actually haven't seen any upgrade issues yet.
OK. And while futzing with the tablet, I made the touch not work anymore. Oh, wait. Something showed up on screen. OK. Now it's working again suddenly. All right, so there's our 3D cube. There's also a little game here. Anyone good at video games? Want to give it a try? It's basically like, what's that called? Bejeweled? You have to try to get 3 in a row. No? All right. So basically, you just swap tiles by clicking on them like this. Like you swap that one, and then it'll disappear.
Okay.
So give it a try. And the bombs are really good.
The what?
The bombs. Yeah, just click on the bomb.
Nice.
3 combo, level completed, good job. All right, wasn't too painful. So this game's written entirely in Java and JavaFX as well. So you can see even the performance on a little 700 megahertz board is not too bad. Probably the most impressive thing to do with the Raspberry Pi is even though the CPU is kind of subpar, the GPU is really powerful. So you can play full screen 1080p movies on your TV at home or touch screens, and has really good performance. And then you can do overlays with your Java application on top of the movies. All right, let's see which one I got. Yeah, so there's the Iron Man trailer. And if we click on it, you can see the JavaFX controls on top, so we can pause and play. Change the volume, exit it. I don't have it hooked up to the sound right now, but if I had it hooked up to sound, you would also hear the sound from the video. So. No, so all this is a few simple UI widgets done as an overlay. It's really easy to do simple graphics in there's some built-in controls, but they look like real buttons and stuff. So it's much easier to just do your own either graphics or simple vector overlay like this. And actually, the way this is working is the video is playing directly on the Raspberry Pi hardware, and the JavaFX frame buffer is sitting on top of it with a transparent background. So that's why it looks like an overlay when it comes back up. OK, so that's the Duke pad. Let me see if I can resurrect my cable from this monster. All right, so I would pass this around, but since I'm using the version without a battery, it's slightly more difficult. But later on, you're welcome to come up and play around with it. All right, and here's some pictures of the Duke pad in production. So like I mentioned, it was entirely cut out using a big sheet of acrylic on a laser cutter. This is the initial 3D mock-up showing the different devices inside of the case. We did it at the Silicon Valley Tech Shop. So you can get memberships there, and then with a simple afternoon class on training on the equipment, then you can go in anytime you want and borrow the equipment to use it. So Jasper, one of our demo engineers, cut out a big piece of acrylic, and then we popped it out and stacked the layers together. There are some of the internal components, the battery. This is the bottom layer of the Duke pad. So the bottom layer of acrylic plus some metal pawls to hold it together. Another layer with some devices layered inside of it. In the center there, you can see the accelerometer, which we have, and then the Pi camera as well with the ribbon cable attached to it. Another photo with even more stuff layered in. And this is one of the other guys who works in the demo team, Gary Collins. He's probably has the most fun office at Oracle. His job is testing all the new hardware which comes in and making sure it's compatible with Java SE. So he has just about every cool development board on the planet in his office. And he always has his favorite new board. So I'll show you his favorite new board of the month. This is, we haven't actually gotten one of these yet because they're not quite released yet, but it looks really cool. So there's a company called Hardkernel, maybe. And they do a bunch of different devices that will run both Android and Linux distributions and have Raspberry Pi compatible and IMX6 chips. So for a while, we've been playing around with the U3 on the left. This is actually the fastest system to date that we've tested that runs Java SE and JavaFX flawlessly. It's almost like desktop performance. It's a 1.7 gigahertz quad-core IMX6 processor. So I think it's about the same as the latest Samsung. What are the Samsung phones? S4? I don't know, whatever the latest Samsung phone is. It's pretty close in specs. The other guy on the right is Gary's new favorite board, his new dream board, the Odroid XU3. But that one has multiple processors, what is called heterogeneous multiprocessing. So it's like a little supercomputer on a credit card. Anyway, they're cool to check out, and they're not that expensive, right? So the Raspberry Pi was $35. The U3 is $65, and that's like a Raspberry Pi on steroids. And it also runs Java SE embedded really well right out of the box. And then we're going to do some testing on the XU3. So I can't recommend it right now since we haven't actually got one to play with. But once Gary gets it and he gets Java working on there, then that should be a good platform to play with as well. The other one, which we haven't played with yet, but we think should be fun, is their Odroid W. It's a Raspberry Pi compatible board, so same processor and specs as the Raspberry Pi, but it's designed on a little tiny wearable board, so you could actually integrate it in mobile and wearable projects. One of the biggest issues with the DukePad design is the case had to be a certain thickness to account for the Ethernet and the USB headers on the Raspberry Pi. Using a board like this, you can make a really flat, slick DukePad. OK, so that's Gary. He's a really cool guy. And here's the DukePad website if you wanted to build your own. The instructions, the code is all open source. The graphics files for cutting out your own stuff using a laser cutter are all there. So you can actually go there and build your own DukePad if you want to from scratch. You can also run the software on a not so fancy Raspberry Pi with just a normal touchscreen. It's going to work fine. But we're gonna switch to slightly more generic devices. So what is this guy? Yeah, so iPhone 5S, I think. And normally, this device is not something you'd expect to be running Java. But using OpenJFX, the open source version of JavaFX, and RoboVM, together, you can run Java and JavaFX right on your device. So one of the early examples for JavaFX was the fish sim application. So it's a little hard to see. I'll pass my phone around, but you can click, and the fish will follow wherever you click on screen and swim to that spot.
What's RoboVM?
OK, so there was a question. What is RoboVM? So RoboVM is a cross-compilation framework. It takes your Java code on desktop, and it actually takes the entire JDK. So the first time, it takes a little bit longer because it has to cross-compile the entire JDK. And it cross-compiles that to native code so that you can then deploy it to devices as IPA files. And what I used to build this was a very simple NetBeans plugin. So if there's also they have instructions on the website for using Eclipse. You can also use NetBeans, which is what I used for my quick deployment. There's a JavaOne iOS plugin for NetBeans that you can simply install in your IDE, create a new project, and then you have a working here it is, JavaFX for iOS support. Sorry if that's a little small. Maybe that's better. So you install this plugin, and then you have a working development environment for building iOS applications on your computer. One limitation right now is you have to have Xcode and the command line tools installed. So if you don't have a Macintosh computer, it's hard. Not impossible, but it's much harder to develop for Apple devices. Also, you have to go through the normal store provisioning and certificate process. So my first project was like, 10 minutes of this. And then 2 hours of dealing with Apple's horrendous certificates and provisioning. I had some old certs on my system which expired, and you have to get them out and reissue new ones and reinstall it and fix all their tools. And Xcode's UI is also, I don't know, in my opinion, way too cluttered. There's just way too much stuff. But once I got it working, it's fairly easy to develop and build your own Java applications. Then you can deploy to Apple devices directly. The Maven script it generates will download RoboVM for you with the right version, compile your all project, and then generate an IPA file that's ready to either be deployed on a device or submitted to the store. And speaking of store submission, there's already a bunch of folks who have built applications on RoboVM using OpenJFX to publish to the store. Mostly games, but there's a bunch of different applications you can build where you can leverage Java as a foundational technology. From the end user's perspective, they don't even know they're running a Java application. It just looks like any other application which they'd be downloading and installing on their phone. Sasha, question?
What is the size of the installer?
Very, very good question. What's the size of the installer? So the base installation for like a plain vanilla, Hello World program is 30 megs. After that, it's a modest increase for like normal code. So this is not something you want to build your Hello World in. But for most applications, by the time you add all the graphics and the assets and you actually build a real business application, on my phone, the average app size is like 50 megs for stuff I've downloaded. And a lot of apps use frameworks like this. They use 3D frameworks and other packaging frameworks. They don't write native Objective-C apps. And the tolerance for apps, both for consumers and end users, has gone up quite a bit since the iPhone came out. So. Oh, there was another question, yeah.
Can you mix with RoboFX, mix Java and Objective-C in the same compilation?
OK, so the question is if you can mix Objective-C and Java. So I haven't tried it, but by default, RoboVM generates a project which you can then tweak and edit. So if you're good at Objective-C and app packaging, you could probably kind of untangle what they've done to hook the Java code in and then do your own stuff under the covers. OK, so something good to try. Again, this is like a afternoon or weekend project. You can get Java running on your iOS device. And see, this would be a good presentation. Should I get closer here? So this would be a good future presentation for the SF Android group. I have a longer version of the Java on Android talk where I actually go through and build an application from scratch and show all the stuff. So in the future, if you want, I'll do a talk on this for your other group. But you can also deploy exactly the same applications that you run on desktop, and you can now deploy on iOS, and you can also deploy on Android devices. So the disclaimer on the iOS stuff and the Android stuff is that these are not officially supported Oracle releases. This is OpenJFX. So I've mentioned this a few times. OpenJFX is the open source version of JavaFX, which is in OpenJDK, the open source version of the entire Java library. And this support got contributed from Oracle back to the community. But as a company, we're not going to offer you like support and maintenance and all of the things which you get for Java as a commercial project. But there's folks in the community, so RoboVM for iOS and the JavaFX ports team, which is led by Johan Voss. You can see here. They're supporting getting Java working on Android devices and doing additional development and bug fixes and stuff to make it a better platform to develop and deploy on. So I've got another device here. Anyone recognize this guy? OK, this might help. Yeah, so this is the ASUS transformer. Just happened to be the best Android, well, the most powerful Android tablet at the time I was getting one a couple years ago. But I think since then, what's the most modern kind of fastest Android tablet? What have you been excited about, Sasha? Nexus 7. Yeah. OK. So anyway, it's a fairly capable Android tablet. And I have a couple programs installed on them. So one of them I'll show you the desktop version first. So one of the applications I use to teach lambdas is called Mary Had a Little Lambda. And the idea is that it's a game where you have a little character that you walk around a map in 3D, but it both demonstrates the lambdas concepts or the Java 8 constructs by showing you best examples, but also the game itself is a, let's see, I was playing around with this with the kids as well. I think I put it back. The game itself also visually demonstrates the streams library. Has anyone tried the new streams library in Java 8 for folks who have been playing around? OK, a little bit, a couple folks. So the way you get a stream is you can do .streams on a collection, or you can call generate or iterate. So this uses iterate to generate a bunch of lambs. And then it also has a filtering command. So I'm using filtering for every fourth animal to change the color of the animals on the rainbow. And then you can also have collections methods to get added to remove stuff from collections. So this cooks the animals for our friendly homeless people. And then we get some eggs, and we hatch the eggs. And then we get some more eggs. And this is what the kids do when I give them the game, is they just make a lot of animals. And eventually you feed the fox, and you get a nice, happy, hungry fox. OK, but it also, using retro lambdas, because Android doesn't support lambdas yet, you can get the same application running on the Transformer Prime with a touch screen. So I'll pass this around for you guys to try out.
Is it packaged the same way as the Java VM?
Yeah. So an APK file, deploy to device. It works under both runtimes, ART and the Dalvik runtime. And yeah, I mean, it's basically an Android application with a JavaFX user interface. The advantage being that now your UI is portable to desktop as well as your Java code. So what's the question?
It bundles the JavaFX plus OpenVDK inside an APK.
Yeah, so the question was if it bundles the JavaFX classes inside your APK. And it does. So when you deploy your Android application to the device, what you get is you get a bundle which includes both your application and also the JavaFX classes inside of your APK. I know Johan's expressed interest in having JavaFX be officially supported by Android. He's outside of Oracle, and he's interested in seeing that happen. But that would have to be something which Google would have to make happen. So it would be officially supported on more devices. OK, so any other questions about Android support or iOS support that I just showed you guys? Sasha?
You package, so JavaFX also has dependency on Java 8 libraries?
No. So the version of JavaFX used on Android, they are maintaining a backport to Java 7. So the iOS I showed you is using directly the Java 8 UI classes. The Android version's using the Java 8 JavaFX classes, but they're backported to work with Java 7 as the underlying runtime. And the JavaFX team knows he's working on it, so they're trying to not depend upon too many Java 8 features, which they don't really yet. But at some point in the future, it's going to become harder and harder to keep the backport going unless either Android devices support Java 8 or Oracle officially supports Android as a platform. But good question. That shows that you know a little bit about the technical issues which Johan has to deal with on a regular basis. OK, so with that, I've shown you guys Java working on LeGOs, Raspberry Pi, the homebrew DukePad, a consumer tablet, a cell phone, and, well, what's this? I got one more thing. Anyone know what this is? Okay, so close. It looks like the Samsung watch, but it's the the very finest China ripoff Android watch, the ZG Pax. I think in my experience, the battery life is like half a day. So it's not that practical, but it actually has a faster processor than the Samsung one. And I have a little JavaFX application running on this as well, a little clock UI. This was designed by Garrett Grunwald. It's called Clock2. And it displays the time as words that flash. If you swipe down, it changes the language. So now it was previously in German. Now it's in English. If you swipe to the left, then it changes the color. So you can see the color of the screen changes. And if you double tap, it will change it to numbers instead of words. So if you double tap, you can switch between like highlighting words or numbers. So I'll pass this around as well. All right, so with that, I want to thank you guys very much for coming to see the presentation today and see Java running on a whole bunch of devices, embedded, consumer, and otherwise. And I hope you guys will take the opportunity to try some of the Java SE and Java ME embedded builds and try it on some devices that you have or you're interested in acquiring. So thank you.
If you guys have a few more questions, feel free to ask. Have you heard of anyone putting Java on Arduino?
OK, so the question is Java on Arduino.
I haven't heard of anyone, just curious.
Yeah, so unfortunately, Java, the Arduino processor is a little bit small, even for Java ME. The EHS5 chip I showed earlier is a Cortex, I think, M3 processor. That runs Java ME pretty well. And it's similar like power and capabilities as an Arduino chip. There was some talk about supporting some of the larger, newer Arduino chips, but I'm not sure what the specific support is for different platforms. Part of the problem with small embedded devices is to support them, you have to have a fairly large investment since you have to build a lot of the OS and the device and the drivers and everything from scratch. So we support a lot of the Freescale and the ST Micro and some of the people we have partnerships with on devices, but there's such fragmentation in the small chip space that it's impossible to support them all. A good one to try for Java ME is there's an ST Discovery board by ST Micro. And that's a really tiny chip, but on a development-sized board with a lot of headers on it. And it's fairly inexpensive. I think it's like a $20 board, so even cheaper than Arduino.
100% the same or not?
Mostly the same. I mean, originally the Java SE embedded builds were called Java SE for ARM because you have to port it to a different processor set. But beyond that, it's basically the same. There's slight variances in like what exactly is included in it. So we strip out like the web view and the media classes from JavaFX. I think we don't include libraries like Swing and AWT because they don't work on mobile devices typically. But there's different sets of stuff we'll include on the embedded distribution. But the code base is largely the same. If you use OpenJDK, there's actually the standard OpenJDK build now supports ARM. So you can build OpenJDK for ARM and deploy it directly to devices. The only thing it's missing is the just-in-time compiler, which comes with the official Oracle SE embedded distribution. OK, so what was the second question again?
Like, so the phone market seems to have
Oh, phone market.
in the Android space. So what is the actual use case for Java ME? Like, what are we
OK, yeah. So all right. So for the first one, for profiles, Java 8 introduced a bunch of different compact profiles. So the way it works is there's a special packaging tool. You give it the JDK, and you give it a bunch of arguments for like what you want it to build a JDK for, and it'll strip it down to a specific set. But those sets are fully JCP certified, and they're allowed by the Java licensing. So you can use those compact profiles on devices if you don't require the entire JDK. I think you can even use them on desktop as well. You can use them anywhere you want to. There's a new web profile as well that you can use for server applications if you want to do cloud-type applications using the same profile support introduced in Java 8. For the second question about Java ME, so it's no longer, Java ME no longer stands for Micro Edition, Mobile Edition. It used to be specifically for phones. Now we've changed it to Micro Edition to represent that it's used for embedded devices besides just phones. And there still is a lot of use of Java ME on legacy feature phones and devices like that. But all of the active development is for generic embedded platforms, not for phone development anymore. So we're primarily targeting Java ME right now at embedded devices in that market space rather than specifically phones. Yeah, so they do some testing of swing and AWT on the device depending upon what the device drivers support. But in general, that's not something which we're optimizing and really trying to make run fast on small devices. The advantage of JavaFX is since it's hardware accelerated and it sits on top of Linux and Macintosh OpenGL on Windows Direct3D, it was an easy port to EGL for mobile devices. So that way you can get direct access to the 3D hardware, which, as I showed you for the Raspberry Pi, the 3D hardware and video decoding is much more capable than the processor. So for a lot of embedded devices, the way you get your performance is by taking advantage of fast, multi-core, highly parallelized GPUs. And that's what JavaFX does by writing directly to the frame buffer and supporting EGL. So if you're doing embedded applications, I'd highly recommend targeting JavaFX rather than targeting legacy toolkits. The other thing which was introduced in Java 8 is there's a separate style for embedded applications. When you build an application using controls, it has more of a touch screen look and feel for your JavaFX UI, whereas on desktop, it'll have standard scroll bars and buttons and widgets. On the mobile devices, for example, the scroll bars disappear and you have a simple touch drag area. The text areas are larger and they have a pop-up keyboard which comes with it. On a lot of the embedded platforms, there's no built-in keyboard like you get on phones and tablets. So JavaFX has its own built-in touch keyboard which will pop up if there's no device-supported one. So for Java SE, it's typically on a Linux-based system. Java ME now can also run in a Linux distribution. So our Raspberry Pi distribution by default deploys into the Linux distribution that's on the device, Raspbian. On smaller devices, they have the capability to be the operating system. At one time, the way Java ME worked was almost exclusively like a packaged programming environment operating system whole device stack. But they're moving away with that because it's very hard to support for new devices, and it tends to be, you lose a lot of the advantages of having a general purpose operating system underneath you. Yeah, so you can use the same sort of sandboxing stuff that you use on desktop. If you wanted to isolate and use the Java Security Manager, then you can have different access if you want to access like network or different services from a subportion of the application. So the same model applies to mobile devices. Just if you looked at traditional C development, you don't really have those capabilities or ways of sandboxing applications easily built into the C compilers and infrastructures.
And so that means no JNI basically, right?
You can do, well, that's another thing you'd have to get permission for if you were inside of a sandbox. Typical Java SE applications inherit permissions from the operating system. So they'll behave just like on desktop. If they're run as root, you get pretty much access to everything. But if you run as a user with less permissions, you'll get degraded permissions. And then if you choose to, you can load jars or modules with restricted sandboxing. We could just keep chatting all night.
How did you get such a cool job?
So that's a good question. That's a fair question. He's wondering how I got the job, the evangelism gig at Oracle. And I think for a number of years, I was basically doing it for free. So I would hang out with the JavaFX team because I wrote a book on JavaFX, and I would speak at their events, and I travel at my own expense to go speak at conferences at different parts of the world to help them out. And my wife hated me because I was never home because I had a day job and I had a night job. And eventually they said, oh, well, why don't you join us and we'll pay you to do all the stuff you've been doing for free. And that was a hard offer to turn down. But I can't recommend the path to get here, at least the way I ended up.
Cool. Well, if that's all questions, thank you, Steven. If you guys want to learn more, I guess we'll invite you to the Android Duty Group. We'll continue the conversation. Thanks, guys.
All right, and feel free to come up and play with the devices on the table.